Hello, everyone. A very good afternoon, and I welcome you all for today's masterclass. This is a retrofit information support and expertise event funded by Department for Energy Security and Net Zero and delivered by Turner and Townsend. Today's masterclass is on optimizing social housing through data with DG Cities. And we have our two lovely external presenters with us, Balaz Zuar, Director of Innovation and Net Zero DG Cities, and Richard Parkin, who's a Senior Assistant Director of Repairs and Investment from Royal Borough of Greenwich Council. So, without much further ado, over to the presenters to introduce themselves.
Good afternoon, everyone. I'm Balaz Chawar. I'm Director of Innovation Net Zero at DG Cities.
And I'm Richard Parkins, Senior Assistant Director of Repairs and Investment at Greenwich, responsible for capital works, repairs, safety, and pretty much all the investment in housing stuff.
What we will be going through today in the next about half an hour or so, and then very happy to answer any questions, is around how we have been essentially using more and more in-depth data analysis to help kind of really rethink kind of the way capital funding is being allocated to places, and also how kind of the new insights are able to help with lots of other various use cases within the work of the housing team. Maybe first a little bit of an introduction to us. So we have sort of already done this. In terms of DG Cities, it is an innovation company owned by Greenwich Council. We were established to really kind of help and kind of think about new technologies, new approaches that could be brought into the way local authorities work and deliver their services. Data analysis, the use of AI, some of the things that we are kind of really exploring now and kind of implementing them or kind of putting them, these new technologies in place within the housing sector has been one of our key focus areas for the last few years. We also have kind of a behavioral insights team and kind of working on also external evaluation of similar programs as well. I can sort of do this. So kind of Greenwich has about 300,000 residents, one of the London boroughs. In terms of its housing stock, which is kind of one of the key focuses for today, manages about 20,000 properties and an additional 5,000 leaseholders properties. It has a very kind of mixed portfolio of all the kind of high-rise buildings all the way down to kind of street level properties as well. The housing stock is very mixed. Some are kind of really quite old, some are much newer. So the data analysis challenges have been looking at really all sorts of financial problems. Probably kind of a good place to start is kind of really think about what is it that we have been doing and why we have been doing it. And kind of through conversations with Richard and his team, it became kind of evident that kind of it would be a really possibility to use all the data that the council and kind of especially the kind of the housing team gathers around its stock, but doesn't necessarily use for kind of all the capital work program kind of setting kind of decision process, primarily because all the kind of the various data sets sit often in different systems or are often in very kind of not analysis ready form. There are kind of sometimes data gaps, as well as a lot of the data is unstructured, often in sort of written text format. So what we really started kind of the whole project with is around, identifying what data is available and kind of really thinking about kind of the creation of a methodology that will allow us to kind of do something with it. So we kind of have been kind of essentially connecting kind of stock condition data, which is, had in a kind of keystone system, often kind of at the time when we started the project quite old and surveys being done only on a proportion of the stock. All the reactive repairs data, so kind of data that is held in NEC systems, which is kind of many years of really good and interesting data around kind of repairs, reactive repairs, but always kind of in an unstructured way, kind of as work order descriptions or kind of as kind of categorized as SOR codes or as kind of work programs, which were not necessarily always correctly inputted in some of the operatives. EPC data, in Greenwich's case, is kind of held by parity, but there are kind of various other EPC data sets kind of in existence. And then kind of other data sets as well, kind of thinking about kind of customer feedback, kind of the data that kind of the customer surveys generate, or kind of any other kind of wider data sets as well, or kind of socioeconomic environmental data sets. So kind of the key question was, okay, this is really good. Kind of you have lots of different data sets, but how is it that we can kind of really kind of start kind of connecting them? And what is it that we could then do to make sure that we are able to sort of say kind of with quite good confidence what works are needed, where, kind of at basically down to an individual property level, and when, which kind of an element of prioritization and kind of optimizing based on kind of size of spending programs per year kind of really becomes the key question. What we essentially kind of started doing is to really think about the prioritization element of it, because a lot of work is expected to be needed over the coming 5-10 years on the stock. And what we really wanted to sort of see is how to make sure that the funding goes to, let's say, in year one, to the properties with the highest priority in the kind of area, asset groups or estates of the highest priority. So we categorized 7 types of kind of key capital work programs, kind of, replacing bathrooms, kitchens, electricals, boilers, insulation, roofs, and windows, all the kind of key programs that can happen and will happen for every property. And we really wanted to give a reg rating, so the red, amber, green rating for every property, for every type of those works. And then also think about kind of the interaction between individual properties as well as kind of the asset groups that they might sit in. Asset groups would be a group of properties of the same archetype, built at the same time, within the same kind of very much small geographic area. And kind of really think about, okay, if we are doing something at many of the properties on this street, say, then how do we create a program which does it for every property on the asset group? So kind of going down to both individual property levels, but also kind of grouping to asset group level, essentially. And based on all the analysis, we were able to kind of create that reg rating across the whole stock, which kind of based on the methodology we created suggests that about, say, a bit more than half of the Greenwich stock is sort of green, kind of without any kind of immediate priorities. And you have about another kind of 30% with kind of maybe 2-3 issues in properties. And then you have a kind of a small subset of properties with a number of those sort of capital works requiring urgent attention. The methodology was sort of shaped in a way that this sort of result was what we was getting, because this is how we felt you can prioritize. I mean, one of the kind of key reasons why we also started to do this, because if one looks at only stock condition survey data that looks at individual property levels, but doesn't necessarily compare one property with another property, kind of maybe somewhere else in the city. So if every property is sort of deemed to be in a certain condition which needs doing, in 2025, you could end up with, your whole housing, so basically needing new windows next year, which basically is kind of unfeasible and cannot really be delivered, both because of funding and both because of kind of just resource constraints. So the additional layers of data really helping to prioritize and really to kind of stretch that timeline to be able to say, okay, we're not saying that all these properties are good, but we are saying that, there are ones that are a bit worse that should be done in, let's say 2025. And there are some which are not that good, but, could be kind of on the almost like in the pecking order, will be done in 2028. Another layer of kind of thinking that goes into it is how you identify kind of poor data sets. So even though we are pulling in from multiple data sets, which allows us to kind of really pick up potential problems with properties across almost multiple indicators, there is still a potential that properties just come out to be just fine. You somehow don't have any information that would suggest that they have any problems with it. But kind of by comparing this kind of deep analysis on an asset group level, where asset groups, as I mentioned before, can be often quite small, like 20, 30, 40 properties, you can really identify that maybe 5 properties out of 50 just look green, no problems, but all the other 45 seem to have lots of problems with something, which starts highlighting kind of these silent properties, potentially ones where nothing got reported, maybe because of the tenant didn't report it, maybe because we kind of didn't collect the data or didn't get captured somewhere, which is kind of really helpful indicator of where certain kind of maybe early surveys should be done, or kind of how kind of holistic kind of improvements can be scheduled so that, a property maybe doesn't become problematic over time, like all the other neighbors maybe have had. One of the elements where kind of this prioritization comes from is really the repairs data, where we felt that if we could really understand kind of as a good indicator how often, what sort of works are we doing at properties, that actually gives a very good indication of the state of that property. It doesn't replace a stock condition survey, kind of the actual human physical survey, but it does give a really good indication. Like if you're fixing, damp problems at the house, twice a year, that does give you a good indication of the condition. If you're fixing, that many damp problems in a block, that gives indication of how the block will be without necessarily even having to go out. So we used AI to read through essentially 4 years of repair kind of conditions and kind of repair history and categorize those. Kind of going from, as you might see, on the left side of the screen, just this sort of basically the telephone conversations that get captured by operators that, are kind of quite random and, somebody would need a lot of time to read them. Kind of keyword searches don't necessarily would work on them. Large language models are actually really good at kind of capturing the essence of those and categorizing repairs into a number of categories that then we can really analyze. We can sort of start counting them both at an individual property level as well as at asset group level. And then based on kind of the needs of that property, we can actually also say, okay, this is the sort of capital spend that we are expecting at that asset group, at that property. So not only creating the analysis, but also almost immediately giving the answers as well on sort of what prioritized investment will be needed for those properties. We are also able to sort of check not only sort of how often these things happen, but also what proportion of properties in certain asset groups have an issue. That also kind of gives an indication of what priority certain kind of property group will be when we are sort of putting them into kind of a year-by-year program. What we're also able to do is kind of consider multiple priorities that someone might have with their housing stock and create almost a prioritized list of projects. So the way, for instance, we went about identifying the SHF kind of wave 3 list of properties that we'd like to kind of be targeting, we used kind of this data set. So kind of once the data set has been assembled, it really only took a very short amount of time to actually get to a prioritized list of asset groups where we could say, actually, we are trying to focus on properties of a certain archetype. We're trying to focus on properties that have a high sort of retrofit need, kind of a priority for sort of both windows, insulation and roofs. Maybe don't have that many leaseholders because maybe we don't want to kind of focus on leaseholders that much, as well as maybe properties where we also have a lot of damp and mold issues, which is also something that is kind of how can we use kind of retrofit also to be addressing kind of maybe damp and mold in the right places. So once you kind of put all of those together, you get a prioritized list of properties, and that is something that is data-driven. It's kind of all been selected, and it's been selected from across the full portfolio of homes, not necessarily only kind of a subset that might, add, the most of maybe recent complaints that kind of is at the top of people's mind, but it's actually something which is kind of really data-driven based on it. And also can be sizing the projects into kind of, small ones and kind of also at the same time estimate the budget for it, because we sort of know how much these sort of projects usually cost. And so we can estimate based on what the need is, how much the project will be costing, so that we can actually size projects to a certain size that we want kind of very quickly, and then kind of review the effects of those changes. What we can sort of also do is start kind of really creating, based on the same principles, sort of optimized work programs. So obviously the council kind of manages and kind of works across has to deliver across multiple objectives. So there are ones where, you need to kind of do, carbon reduction and kind of aim towards net zero. At the same time, reduce damp and mold and kind of make sure that you're doing kind of proactive works at properties which might have lots of damp and mold cases. At the same time, meeting decent home standards, kind of fixing kitchens, fixing bathrooms, kind of reinstating properties, thinking about EPCs and kind of bringing all the EPCs kind of higher up to EPCC. And there kind of might be kind of a number of other objectives that a certain organization kind of has by their priorities. So having all of that kind of and putting the properties on it, one is able to kind of start creating optimized plans. So you can say, well, actually, in year one, we're going to be focusing on these type of properties. And in year two, then it's going to be a different set of properties. And based on that, kind of putting the properties into kind of really an optimized kind of program years, setting kind of year by year kind of budget limits, either for the whole kind of spend profile or for kind of the very specific elements, sort of how much we want to target. I don't know, maybe kitchens. Let's say there's a 1 million kitchen budget. Okay, let's try and make sure that we are finding the most important properties for that 1 year project. Also thinking about how, if you need one thing 1 year and the next thing the next year, often it's better to kind of combine some of those projects. It's kind of how do you also do that at the same time? So what we have basically kind of created from really all the data is to be able to do that, and is to be able to kind of place projects on a year by year basis, kind of in an optimized manner. And that what it really allows one to do is kind of communicate very openly with any sort of stakeholders and kind of justify kind of budget requests, and also to be able to kind of share some of that data with more information with officers, politicians, and kind of public at one point, because you are able to sort of really pinpoint and justify kind of decisions on why in 2027 we're going to be doing those sort of projects. It's because before we have other priorities, but some other projects will kind of happen up. I know that it sort of might look, very nice and just colorful, but at the same time, what it helps do is kind of once you do a methodology sort of behind it and kind of make the decisions without seeing the answers, kind of once the answers are presenting, what one can do is kind of not change the actual answers, but sort of change maybe the methodology behind. Like if we feel that the analysis is not giving the type of results that people are finding on the streets or kind of when going to properties, then we can really rethink the methodology. We can rethink how we are using the data, how we are cleaning the data, kind of what data sets we are using, to then kind of try and give results which kind of on the ground are actually kind of visibly being kind of helpful. It also gives a really good indication around kind of when talking to kind of contractors who might be kind of suggesting certain properties or certain areas to be worked on, because you can actually see kind of comparatively how bad or maybe how far down kind of your optimized list those properties are, to be able to kind of have conversations with contractors saying, look, we understand that those properties are important, but we think we have kind of other groups that are ahead of them. So, let's sort of see how we kind of shift focus on them. And kind of that's what working through this process really allows one to do. And also then see progress. So kind of once you are able to kind of report, how the number of EPC DEF properties are reducing over time, that's sort of not a random number, kind of 200 per year sort of reduction, but it's actually based on kind of real stock, real assets within it that being placed in the program. So it's kind of becomes quite easy and powerful to communicate with. One other thing that we think is kind of really interesting kind of when going through this sort of process is around how one kind of starts thinking about evaluation. So kind of thinking about kind of wave 2 and kind of moving towards wave 3, just kind of thinking about the retrofit program, but is applicable elsewhere as well. Evaluation often comes at the very end of a project where people start thinking about it. Oh, okay, let's make sure that we evaluate it. But at that time, you might realize that some of the answers that you would like to have, you didn't sort of collect data for it. So kind of creating this sort of data set gives one a really good baseline to be able to sort of see changes from. Because we think that what makes sense for evaluation is kind of ask questions at the beginning, like, I don't know, simple questions are, would we work with this contractor again? Or, did we select the right properties? Or did we have right internal processes for this sort of program? If you ask those questions at the beginning that you would like to answer by the end, you can sort of put in place, some data gathering processes to say, okay, let's kind of collect this data so that by the end we are able to answer it and say, well, actually, this contractor was really good. This other contractor we worked with wasn't good because of certain reasons. Therefore, going forward, we might consider how we kind of deal with that. Or internal processes wise, like, did we have the right sort of contracts? Did the contracts give us all the flexibility or kind of all the powers during the project? You can sort of gather during the project kind of the small answers for those questions. But at the very end of it, if you didn't do kind of the work before, it becomes extremely difficult to really justify often kind of gut feelings from officers where they might say, actually, it wasn't really good. Can you justify it? Well, and then you just might get anecdotal evidence. But if you're kind of collecting data, you are able to kind of have really hard proof evidence about it. So one of the things there that you can look at is sort of, is it worth investing in certain properties? So kind of looking at sort of net present value of individual homes, is it a good place to spend that much money maybe per property level, or actually it's not delivering that sort of level of kind of return on those investments? Or if you look at kind of, we call it kind of neighborhood scores, which is kind of a combination of environmental, social, and economic kind of indicators as well of kind of the properties where they are. One is able to say, okay, let's invest in properties with kind of maybe a bit more kind of economic deprivation as well, and sort of see how that actually helps that community kind of grow, or kind of that neighborhood kind of really bounce back potentially from some stresses. So all of those sort of nice secondary impacts as well can be measured once sort of somebody kind of builds those through it. Things that we are doing around it are kind of how can we follow kind of contract, kind of, what the contractors do, which contractor is doing it, kind of customer satisfaction, at those individual properties, what works are done, how much they cost. Then, can we try and measure effectiveness of those investments? And then you can really kind of start painting really nice pictures around, okay, when we did this in kind of cavity wall insulated homes with this contractor, residents were really happy. Over time, we can see reduction, say, in damp and mold cases from the repairs logs. Whilst in these other places, let's say we did these solid wall homes with this other contractor, didn't actually work. Why did it not work? And therefore, would it be a reasonable thing for us to invest again this much next time around in solid kind of wall properties when, the original, 200 homes we didn't actually kind of give the impact? So I think a lot of that sort of thinking around, where does it make sense to invest? Does it actually deliver the returns? Can be done once you have the really good baseline data sets that I kind of try to show how we have kind of gone about achieving. A few benefits, which I think I've been kind of mentioning throughout, but I think one of them is really being able to be kind of confident that one considered everything. So I think on a project by project level, it's often easy to sort of say whether there is kind of good reason to do something or not, but that doesn't put it into the full context. Like once, organization starts having, 10,000 plus properties, it's hard to always appreciate kind of the impact of doing one area and not another area. Similarly, kind of what we found is that, people often remember, that block is really bad, but they don't necessarily remember that, that little cul-de-sac of 30 houses is also really bad because, one operative often goes out there and often fixes the same type of issues, but maybe they don't have a politician kind of, voicing their concerns. Maybe always different person goes out to fix issues and, doesn't really generate organizational memory. So you kind of actually start forgetting certain areas that might be bad. Having the data kind of really manages to kind of push some of those groups up the priority list. I think one of the things I mentioned is that Greenwich is looking at focusing at stock condition surveys to kind of try to, obviously there's an urgency to kind of get to 100% stock condition surveys over the coming years. That's always going to be a ramp up. You always need to start somewhere. So we're using some of this data to focus the stock condition surveys in, next years to really go out to places where we think there might be problems or where there might be kind of silent units that we don't know enough about. Kind of creating the spending plans, kind of based on kind of really good evidence, you can start saying, okay, well, this year we need 30 million and this is what we can do with it. Whilst, next year, if we have 20, this is what we can do with it. And actually have a full vision as well of what is it that you're also not going to do. So you can start showing people that, okay, if this is the level of investment, these are the sort of things that will happen to the stock. Kind of talking with the contractors and kind of really guiding them to the kind of key areas can be helpful, as well as kind of, as I mentioned, kind of using all this data as baseline for evaluating programs like warm homes is also, we feel, will be very powerful. I mean, even just looking at the repair data sets, like once you look at, years of, let's say, backlog of, say, just the damp and mold repairs. If you do a program, let's say in a, cavity street archetype, and if you follow that another year, you can sort of see whether all the neighbors are having more damp and mold problems than those, and then you can actually show the value on it, and you can start putting numbers in it as well, because you know how much you spend on those sort of repairs. So even kind of just from a financial standpoint, you are able to sort of start seeing kind of returns on those investments that can kind of help justify future programs too. This might have been, hopefully this was kind of helpful and interesting. I'll ask Richard to kind of say a few words if I have missed something, but I'm very happy to answer any questions, or always happy for anyone to kind of reach out to us about these sort of things. Thanks very much.